Hello and welcome to our fourth learning path in AI-300, Operationalize Machine Learning and Generative AI Solutions. I'm Barbara Andrews, a Microsoft technical trainer here at Microsoft, and I'm glad you're here. Let's get started with this session. What if you could turn your AI agent from a black box experiment into a system you can measure, improve, and trust in production? That's exactly what this section is about. Here you'll explore how Microsoft Foundry and GitHub help teams bring engineering discipline to generative AI, automating evaluations, gaining visibility into agent behavior, and systematically improving performance. You'll see how to automate AI evaluations with GitHub Actions, implement observability, and monitoring for generative AI workloads, and refine agents so that they perform reliably at scale. By the end, you'll understand how successful teams treat AI agents the same way they treat critical software, measured, monitored, and continuously optimized to deliver consistent real-world value. Great AI agents shouldn't rely on occasional manual checks. They should be continuously evaluated and improved automatically. In this section, you'll see how to bring automation to AI evaluation by combining Microsoft Foundry with GitHub Actions, turning what used to be a manual prompt testing into a repeatable CI/CD style workflow. In other words, instead of wondering whether a prompt or model change actually improves the agent, you can automatically run evaluations, capture metrics, and validate results every time the agent evolves. The payoff? The teams can iterate faster, catch regressions earlier, and keep AI agents reliable and production ready as they scale. If you want AI agents that improve with every change instead of quietly drifting off course, understanding evaluation workflows is essential. Here we contrast three ways to assess agent responses. Human evaluation brings deep context and nuanced judgment, great for interpreting complex answers, but it's slow, costly, and difficult to scale. Automated evaluation complements this by applying consistent metrics and running large-scale checks quickly, though it can miss subtle context and still needs validation. A human-in-the-loop approach combines both automated systems handling bulk evaluation while people review critical decisions and edge cases to maintain alignment and quality. Picture a customer support AI assistant responding to thousands of product questions. Automated checks can flag responses with poor grounding or long latency across huge data sets, while human reviewers step in for ambiguous or high-risk responses. The payoff is faster feedback cycles and reliable oversight, keeping the system dependable as usage grows. A strong guiding principle here is to blend machine-driven scoring with targeted human review, leveraging automation for scale while preserving expert judgment with nuance as it matters. When AI evaluation is automated, you still need confidence that the automated scores actually reflect real quality. Let's see how to verify that trust before relying on automation at scale. Focusing on the human-in-the-loop validation phase for AI evaluation. First, teams run shadow rating, where both human reviewers and automated evaluators score the same 100 examples to check alignment. Next comes a correlation check, confirming the scores track closely. For example, aiming for greater than or equal to 0.7 correlation. So automated judgments are dependable. Then disagreement analysis highlights where the scores diverge, exposing edge cases or misrepresented responses. Finally, refinement improves evaluator prompts or configuration to tighten alignment. Picture a product support AI agent whose responses are evaluated automatically for accuracy and relevance. By comparing automated results with expert assessments, teams can identify gaps, such as when the system misses nuanced troubleshooting advice, and adjust evaluation settings to improve reliability. The key takeaway: pair automated scoring with structured human validation early, ensuring evaluation signals remain credible and the system can safely scale to large volume testing. If AI evaluations influence what goes live, you need a safety net that keeps quality high while automation runs at scale. Let's consider how to operationalize a human-in-the-loop evaluation model after the system is validated so that automated scoring can move quickly without losing oversight. This workflow introduces 4 guardrails. An automated gate runs a full evaluation whenever a prompt is updated, ensuring every change is checked before affecting users. Human review triggers flag responses that fall below defined quality thresholds or a sampled portion of outputs for manual review. Ongoing monitoring, such as periodic correlation checks, detects if automated evaluators start drifting from expected behavior. Finally, feedback loops allow reviewers to refine evaluator configuration so assessments improve over time. Picture a customer support AI assistant handling thousands of queries daily. Automated checks review every update, while flagged or sampled responses are examined by reviewers to validate quality. The payoff is faster iteration with reliable oversight, ensuring improvements scale safely while the system continuously learns and maintains trustworthy output quality. If AI evaluations don't match human judgment, your automated metrics can quietly reward the wrong behavior. How can we keep evaluation signals trustworthy? Consider align evaluators with human criteria here that outlines a 5-step process to ensure automated evaluators reflect real-world quality standards. It starts with selecting built-in evaluators that measure the dimensions you care about, such as accuracy, relevance, or groundedness. Next, teams run shadow rating, where humans and automated evaluators score the same responses to check alignment. Once results are gathered, you monitor correlation over time to detect drift as models or prompts change. If alignment drops below thresholds, teams investigate misalignment to identify gaps in the evaluator logic. Finally, evaluators can be refined or extended with custom evaluators when domain-specific nuances are captured by default metrics. Consider an AI customer support assistant answering product questions. Built-in evaluators check grounding and task completion automatically, but an occasional mismatch with reviewer scoring may reveal that domain-specific guidance, for example, internal policy rules, aren't fully captured. By refining evaluators and monitoring alignment regularly, teams ensure evaluation metrics stay reliable. If you want AI agents that deliver answers people can trust, choose the right evaluation metrics is critical. Here are 3 of the most practical signals for AI system quality. Intent resolution. So did the response actually solve the user's problem? Relevance. Did it stay focused on the question? And groundedness. Did it rely on valid sources rather than hallucinating? Selecting evaluators aligned with these dimensions makes evaluation results meaningful rather than misleading. For example, imagine a technical support assistant that answers product setup questions, measuring intent resolution, confirms the instructions actually solve the issue. Relevance ensures the answer addresses the exact troubleshooting step requested, and groundedness verifies the explanation references the company's product documentation. The payoff of adopting a structured evaluation strategy like this is clearer signals about agent quality, enabling teams to prioritize improvements, and deploying responses that remain accurate, focused, and evidence-based as the system evolves. If you want confidence that your automated AI evaluations actually reflect real human judgment, this step is where that alignment gets tested. The slide shows a shadow rating validation approach where the same set of responses is scored by both humans and an automated evaluator. In the code example, a small Python script uses pandas to assemble the scores, and Pearson R for sci-fi stats to compute the correlation between human and automated intent resolution ratings. It builds a comparison table, calculates correlation, and prints the results. This code tells you how well your automated intent resolution scores agree with human evaluations and whether that agreement is statistically meaningful. The printed correlation value, for example, 0.82, becomes a quick signal of how closely the automated evaluator mirrors human judgment. Picture a scenario with a technical support AI agent. Human reviewers rate whether answers truly resolve a customer's problem, while the automated evaluator scores the same responses. By calculating the correlation between those two sets of scores, the team can immediately see whether the automated metric is trustworthy enough to scale across thousands of evaluations. A smart operating strategy is to run those shadow comparisons early in the evaluation workflow and set a correlation threshold before relying on automated scoring. This keeps evaluation signals dependable as the system evolves. Ready to see how AI evaluation can scale beyond manual testing? In this exercise, you'll move from theory to practice by running automated evaluations with cloud-based evaluators. This hands-on lab is where you'll learn to systematically test AI agents at scale, letting cloud services assess response quality quickly and consistently instead of relying on time-consuming manual reviews. You've now seen how automation brings rigor and confidence to AI evaluation at scale. By combining Microsoft Foundry with GitHub Actions and human-in-the-loop guardrails, teams move from occasional manual checks to continuous, repeatable validation of agent behavior. This is the shift from hoping changes improve quality to proving they do. With aligned evaluators, shadow rating, regression checks, and CI/CD style workflows in place, every update is measured, monitored, and validated before it reaches users. The result is generative AI that evolves safely, catching regressions early, scaling evaluation reliably, and delivering trustworthy performance as agents grow in usage and impact. Thank you for joining us for this session. To continue your learning, watch other videos in this course, or explore more on Microsoft Learn at aka.ms/learn.